Hello there. This is lesson 3 at this stage for functions and relations. I'm just going to have a look at some functions here. So a function is a relation for which each x value of an ordered pair there is a unique y value. Sounds quite confusing, but you'll see that below. Basically, if you can draw a vertical line and it only touches the function once at any point, no matter where you move that vertical line, then it is a function. So you can see here our vertical line for y equals x squared. This is a function because no matter where that line moved, right or left, it would only be touching this function once. Whereas here, this is not a function because a line through this function would touch it twice, a vertical line. This is called the vertical line test, which you can imagine is very creative. So that's a good way to test whether something is a function or not. So instead of y equals 2, just as a kind of working rule, we use f of x, or f bracket x equals whatever, in this case a linear equation. So we use that instead of y, which is what you've kind of been doing in the past. And we can even write this as f bracket 2, so we're saying that when x equals 2, what does the function equal? So I'm just going to sub it in as I normally would for x, and of course that is 5. As you've seen in previous lessons, the notation stuff can get pretty confusing. This part in particular is a bit strange. So if we had something like y equals x squared, if we wanted to write this in function notation, we would write it as f colon r to r f of x equals x squared. So that's the function part, so that's pretty straightforward. It's the same as y equals x squared, but in this case it's f of x. This is the domain, so whatever the domain is goes there. And for the moment, I don't think you'll have anything other than r here. It's basically meaning all real numbers in the domain. So in this case, our domain is all real numbers, so of course it's all real numbers anyway. But this next example probably makes a bit more sense. So our domain here was restricted to 0 to 4, which you can see here. And this is saying it's all real numbers between 0 and 4. So it's basically everything between 0 and 4. If that was z, for instance, which is for integers, then it would just be the integers between 0 and 4. 0, 1, 2, 3, 4. That would be it. That would just be kind of coordinates on a Cartesian plane rather than a function or a graph. But anyway, you'll see some of that a bit later on. So that's the kind of function notation. I've got some examples of that down below as well. So let's sketch the following and state the range. So I'm going to sub in these values, and that's just going to be -1 and 2, because at this moment it's just the same as y equals x. So we've got there, probably could have done this a bit bigger, and through there. So -1, -1, 2, 2. And of course 0, 0 is our x and y intercept. These of course are called endpoints, so we definitely want to find the endpoints, and they're solid dots because of the square brackets, so just keep remembering that. And a range, we can just say range equals, and it is -1 to 2. That's not too bad. This one's a little bit trickier. Again, it's a little bit small. You can see I've converted this to, I've written, that is in function notation, sorry, and I've written it in one of the other notations, so it's kind of going back the other way. But let's find our endpoint. So -1, this is going to be -1 squared plus -1, which is 0, and 1 squared plus 1, which is 2. So we have a dot there, and 1, 2, which is here. And this is going to be a bit tricky. Our turning point is at -1/2 and -1/4. Again, probably should have used a better example for this. Let's say it's around about there. I've made a bit of a mistake here. I need to change this to an open circle. Of course, because of our curved bracket there. Zoom back out again. Okay, of course we would label all of these, so I'll really quickly do that. Hopefully I haven't made a mistake there. We'd probably label the turning point as well. And our range would be -1/4 to 2 with a curved bracket, because we're not including that open circle as the highest y value or highest value of this function. Again, still a function. If we drew a vertical line, it would only touch this function once. Let's have a look at this next one. So I'm missing a y = 0 asymptote. Quickly draw that in. Let's change colors for a little bit. So this would be, if we're subbing 3 in for x, so that is at 3, y is a half. Now we've got a domain restriction here. So we're only going from the value of 1 to 3. So let's see if I can draw this as well as I did in class. It's not bad. The reason I'm not subbing in 1 as a value is it is a asymptote. So it's never actually going to reach x = 1. So we don't need to sub that in as an asymptote. So the range here would be, inclusive half to infinity, which of course we do with a curved bracket. Slowly getting there. The textbook does some weird terminology. So if we had the function f of x = 3x + 1, the image is the x values. I believe this is correct. You won't really see this much in year 12, but the image, in this case, x = 2. The pre-image is kind of saying what does y equal, or what does the function equal. Or even in this form, if you've got f of x = 2x, it's the same as saying y = 2x, and you can just sub it in there. So if we were solving these, this would be 7. That's going to be 6. So x = 2. We should write in this. And in this case, we end up with, that's 1x over there, plus 1. So I think we end up with x = -1. I've just done some examples in the notes, so if you want to have a look at that, changing to the function notation, or this f xy. Remember that this part of it is your domain. This is all real numbers between the domain. Pretty much every question will be, you do that arrow r, so just keep doing that. And this is the function. Sometimes you need to rearrange it so that it's in the form y =, or in this case, f of x equals. So for instance, b here, I subtracted 3x from both sides and then divided by 2, so that it was just in the form y = or f of x equals. Hopefully I haven't made any mistakes there. Otherwise, good luck, and just get that notation stuff right. Keep practicing it. It'll start to make sense eventually. And keep doing that vertical line test. That's how you test for a function.